We're looking at the guided notes for solving application problems using systems of equations. And here, this system here has two variables and two equations. And really the big idea here is that variables stand for something and the equations stand for something. And each equation describes some scenario or an idea. That's going to be important, so let's see that in action. So, the first example says at the park there are 38 people playing tennis. Some people are playing doubles, some are playing singles. There are 13 matches going on in 13 matches in progress. A doubles match requires 4 players, a singles match requires 2 players. So part A, write a system of equations that represents the number of singles and doubles matches going on. All right, so first things first, we need to define our variables. Here, let's let x equal singles matches, and y is going to be doubles. And in general, they're going to spell it out for us here. This tells me my variables. Again, we let x equal singles and y equal doubles. And this is very important because this goes into the idea here of what we're going to put together as far as the system of equations. So one equation we can do in terms of people, and the other equation we could do in terms of matches. So I know there are 38 people, right? So we have 38 total people. Well, how many people does it take to play a singles match? 2. So I'm going to have 2x. And how many people does it take to play a doubles match? We have 4 people there. Now notice, it matters what we define our variables as and what we define our equations as. So the people's equation here, total number of people. Well, if x stands for number of single matches, then the number of people in a singles match is 2. So 2 times the number of singles matches plus 4 times the number of double matches equals the total number of people. Now, we can do this in total number of matches as well. So we know there's going to be 13 matches in progress. So here we have 13 matches. If I just simply add the number of single matches and the number of doubles matches, I will get to 13. So here I'm going to have x plus y equals 13. And here we could solve this pretty quickly. I'm going to use elimination. So I'm going to multiply this line here by -2. And yeah, part B says how many matches of each kind are in progress. In other words, solve. So I have -2x minus 2y equals -26. And rewrite my first line here, I 2x plus 4y equals 38. And now when we add our lines together, I get 2y, yeah, x's go, 2y equals 12. So y must be 6. And this helps out a lot, because if y equals 6, I can plug that in right here. So I get x plus 6 equals 13. And taking 6 away from both sides, I get x equals 7. Now, what's the meaning of all this here, right? The number of singles, so there are 7 singles matches and 6 doubles matches. And this would be my part B. Now again, I just want to reiterate the big idea. Define your variables first. Once you define your variables, Then you want to define your equations. And it's easy to pick out what the equations are if you look at your totals. Look, it says 38 people and 13 matches equals 38 equals 13. That told me what the idea was whenever I saw my totals here and here. Then I knew what my equations had to be. Once I define my variables, I can define my variables, and that was hidden in the question itself. Write a system of equations that represents the number of singles and doubles matches. All right, so let's try the next problem here. Mr. Stevens is High School Musical, Oklahoma, where the wind comes sweeping through the plains and the waving wheat just about sweet and the rain. Okay, sorry, I have to do it every time. Drew a sellout crowd on its final Saturday night performance of his senior year. So the auditorium at my high school was exactly 500 seats. The tickets for students was $5 and the adults was $7. They collected $3,076 at the ticket booth for the play. So how many adults and how many students were in attendance that night? Well, that tells me right off the bat what my variables are. So X equals the adult tickets and Y equals the student tickets. And really it tells me right off the bat how many adults and how many students. And in fact, I don't even need to say tickets here. I can just say X is the number of adults, Y is the number of students. Now, what are my totals? What kind of totals do I have here? Well, there are 500 seats, which means they sold 500 because it's a sellout crowd, so they sold 500 total tickets. So my first equation should be in terms of ticket sales, or total number of tickets. And here I know it's going to be 500. And then my second one, here they collected $3,076. So the next one needs to be in terms of money. My total was 3,076. Let me make sure that's right. So the total number of adults and students, well, if I add the number of adults plus the number of students, I should get to 500. So this one gives me X plus Y equals that. Now, how much did they make on each adult? How much did they make for each adult ticket sold? It's $7. So we have 7X, and it was $5 for students, so 7X plus 5Y equals 3,076. I could do this with elimination or substitution. I'm going to choose to do substitution here. And I'm going to solve for Y. The reason why I want to solve for Y is that 5 times 500 I know. I don't know 7 times 500 off the top of my head. So I'm going to solve this for Y, and I get, excuse me, the first equation for Y, and I get Y equals 500 minus X. So now I have 7X plus 5 times 500 minus X equals 3076. I distribute my 5 and I get 7X plus 2500 minus 5X equals 3076. Combine like terms, 2X plus 2500 equals 3076. Take 2500 away from both sides. I get 2x equals 576. Divide both sides by 2. Oh man, I don't know if I could do this in my head. Let's see, 2 goes into 500, so I get 250. 26 is what, 13, so I get 263. is x. Did I do that right? 263, is that right? No, that's not right. That's not right. Let's use a calculator. Quit being silly here. $288. I was way off. I was so far off. I can't believe I tried to do that in my head. Okay, so if x equals 288, I should probably plug that one back into this equation right here. Oh no, it'd be here. This is easier. Let's do this one. Okay, so now I get y equals 500 minus 288. Calculator, I'm not that good. 212. Now, I have to give my answer. I would prefer that we put it in a full sentence. That's okay. We could just simply say there were 288 adults and 212 students. And there we go. Now we have our answer.